Okay, so let's start with this one. We've got binomials, and we can see they're all binomials inside the brackets. So we have to find perfect matches. 3x minus 7, 1 on top, 1 on bottom. 4x minus 5, x minus 2. And now we have 7 and 6, it doesn't match. 3x minus 10, 3x minus 5, they don't match. And we're done. We can't cancel anything else. Doesn't matter that the 3x is repeated. It has to be identical through the whole thing. Monomials is different. We just have to find something in common. I've got 3 on top, 5 x's on bottom. Just cancel 3 of them. 4 and 3. I have 1 left on top. 18 and 21, if I divide by 3. 6 and 8, both divisible by 2. And 4 and 10, both divisible by 2. So it doesn't matter if they're matching, we just have to find something common to both. If I look at the top now, I've got 3 times 5x. And on the bottom, I've got 2x squared 7. 2 times 7 is 14. And I can see that I can cancel more. Take an x from the top, an x from the bottom. Nothing goes into 14 and 15, so I'm done. Back to binomials. So right away I'm looking for matches. X plus 5 matches. There's nothing else. Now I see 2x and 4x, but they're binomials. I can't cancel the 2x with the 4x. But if I look closely, this has a GCF. I can take 2 out of 4 and 6. Now I have matching binomials. So the only thing left on top is the 2. And on bottom, x minus 2. We can't cancel these because this is a binomial, this is a monomial. You can't mix the two. Next one. Right away I see these are monomials in front of binomials. The binomials I can cancel. They're the easiest ones, identical binomials. X plus 1 has no matching partners, so it's going to stay. 24 and 30. What goes into 24 and 30? 6. If I divide both by 6, 4 over 5. And I just want to check one more time. I can see the x's can cancel as well. So I can take 1 x from top, 1 from bottom, and there we go, final answer. So remember, monomials with monomials, binomials with binomials. You can't mix the two. So this one right away, and I want to emphasize, both have 2x plus 7, but this one has the 2 outside the brackets. They are not the same. This side, nothing matches. They're all binomials. Nothing identical. So I'm going to look at factoring. 4 and 14. This can become 2x plus 7. And I can see it's the same as this one here. 2x plus 7. On bottom, it's difference of squares. Cross that out because I've factored it. So 2x plus 7, cancel it. The x plus 7s, cancel that. And all that's left is a 2 and another 2 on top. And on bottom, I have 1 binomial left. So just to emphasize, only binomials can be canceled with binomials. The 4 can't cancel with anything because there's no other monomials to cancel with. So this one, again, we're going to start thinking factoring right away. 3x plus 15. 3 goes into both. 6 and 30, 6 goes into both, and a 6x, because both of them have an x. And now I see there's matching. This one's already factored, so now I'm just going to cancel the binomials if I can. All the binomials cancel. And what I'm left with is I've got 3 times 5x squared. And I have a 6x on bottom. Now, monomials, I just have to look for a common factor. What goes into 6 and 15? Divide by 3. And I can take out 1x. Divide by 3, and the x is gone. So monomials together, binomials together. Now this one we've got matching binomials, at least the x plus 3's. But there's a plus sign in the middle. As soon as we see a plus sign outside the brackets, start thinking something's different. We can't factor these ones, or we can't cancel these ones. But if it's plus, and this is going on to the next section, we just add the x's. Then take the numbers, 3 plus negative 7. Now we can't cancel because they're not identical, but a thought should be, can we factor this? 2 goes into both. And then we see we have matching binomials. There's no plus sign between the brackets, so I can cancel. So if there's a plus sign outside the brackets, be careful. If it's something like a binomial with nothing else up there, this is where we're looking at GCF, unless there's a perfect match underneath. So, binomial, let's do GCF. 3 goes into both of those. 9 and 45, 9 goes into both. 2 and 4, 2 goes into both. And what we see is now we have matching binomials. So on top I have 5 times 9, 3 times 2 on bottom. And 3 goes into both top and bottom. Divide by 3. Simplify. So again, doesn't match any other binomial, so I'm going to do GCF. 3 goes into 6 and 9, so I divide both by 3. 7 goes into 14. 2 goes into 2 and 4. 5 goes into... So now we're looking for matching binomials. X minus 2, right there and there. And this one, be careful, this one's squared. So we can't cancel with this one, even though it starts the same way. So I've got 3 times 2 on top, 7 times 5, like that. Nothing goes into 6 and 35. I can take a look at the smaller numbers. Nothing is common. So, binomials everywhere. Nothing matching. So automatically, GCF. 4 goes into 12. 10 and 35. 5 goes into both. 4 and 14. 2 goes into it. So x minus 3, both places. We've got 2x, plus and minus, they're not the same. So 4 times 2 on top, 2x minus 7. The 5 is by itself, 2x plus 7. So now we're getting into trinomials. We've got one trinomial, three binomials. So nothing matches, factor. Difference of squares, so minus 5 plus 5. Trinomial, 11, the only one is 5 and 6. So if I look through, 5s cancel, 6s cancel. These two don't match, so that's my final answer. X minus 5 on top, x plus 2 on bottom. Going over to this one, two trinomials, they don't match, so I'm going to factor them. One and 6, 2 and 3, 2 and 3 work. So everything's factored. Now look for matches. X minus 3 cancels. X plus 2 cancels. The 4s, minus 4 is, they're duplicates, but they're both on top. So I can't cancel them. So I have two of them, or you can write it twice. X plus 3 on bottom. So factor, factor, factor. Always separate monomials from binomials. Then cancel.